in-class applications. You bought a bond a year ago for $1,027.50. These bonds make annual payments and mature 6 years from now. You decide to sell your bonds today when the required rate of return is 5.4%. If inflation was 2.9, what was your total return on investment? Let's just draw our timeline. Well, this is -1 and this is 0. We bought it for $1,027.5. Let me make sure that's right. It is. The coupon is 5.8% on the bonds. So let me just go up here. 0.058. They're annual, so we don't have to make any changes. So we're going to get $58, and we're also going to be able to sell it. Let's see. All right, the rate that we can get on these bonds when we go to sell it is 5.4%. They make annual payments and they mature 6 years from now. So it's 0.054. The number of periods is 6. The payment is 58, and the future value is 1,000. So that means that we get $1,078.05. So we bought the bond for $1,027.5. We sold it for $1,020, and we got a coupon of $58. And in fact, let me make this a minus just so that we're clear. And we are going to sell it for that. Okay, so again, sale price plus the coupon equals our total return in time 0. We had a minus $1,027.5. And the question is asking, what's our return given that inflation was 2.9%? So I'm going to put inflation out here, 0.029. There's a couple different ways to do this. You could do, let's see. You could pretend that this is time 0 and time 1. It doesn't really matter. It's not going to change your answer that much, but it's easier conceptually for me to explain it to you. Let's guess at a rate. So if we wanted the PV, it would just be this plus this divided by 1 plus, divided by 1 plus R to the power of 1. Since it's 1, it's just going to be the same number, but whatever, we can do that. We can use goal seek here to get the IRR. And we find that it's 4.9%. There are a lot of different ways to do this. I mean, you could literally you could do your own calculation. Another way to do it would be to do 1,000. This is your gain on the investment, and if you did this divided by a negative version of that to get rid of the minus, change that to percent, notice that we get this same exact thing. So here we got the PV, and let me just show you that it doesn't matter if you do it to the 0, but you have to change. Don't do it that way. You'd have to change some other stuff. Well, let's do it that way. Divided by 1 plus that to the power of that. There you go. It's the exact same thing. So if you discount it correctly, and if you use the -1 and the 0, you would do whatever you paid at 0 or -1, however you want to look at it, to the power of that to the -1, 1 plus the interest rate to the -1, this payment to the power of 1 plus the interest rate to the power of whatever time period that is, or divided by, I'm sorry. Anyway, the point is there's two different ways to do this. One way to do it would be an NPV setup where you divide exactly like you would on the problems that I showed you in the first part of the semester. The other way would be to take the gain and divide it by what you paid for it. Both of those ways will work, but the real answer that they want is what is the the total real return on your investment. And whatever interest rate you want to use, you can use them both because they are the same. To get the real rate, you're going to do 1 plus your gain divided by 1 plus your inflation rate minus 1. Change that to a percent. And 1.962 is exactly what we see here. The punchline on all this is that we thought we got 4.9%, inflation was 2.9%, and so we only got a little under 2% return. The inflation wiped away a lot of our gains.